Um, let's talk about your future career plan. Okay, computer science came back to the world with a uh, strong light. Um, it has good envisions. Like when it was about 30 years ago, 40 years ago, 30 years ago, computer science was uh, the major, almost all college freshmen would like to study. Talking about 30 years ago, right? And then we had IT crisis. So many people drifted away to, for example, business, and also financial markets had been so popular last few decades again. And then now we all know that just talking or just playing with money is not really a big issue. It doesn't help, does never contribute to the world. Well, a little bit, right? But something needs to be productive uh, and also uh, help to the society. Somebody who play with money, gather money, gain more money, and put them on their pockets, never contribute to the world at all. But anyway, computer science came back, uh, and now a lot more freshmen, college freshmen would like to study computer science, but not like computer science in general, but coding skills. So, and also major in computer science only uh, will restrict the career path a little bit, narrow. But if you have coding skills together with your own disciplines, then there is a lot of room that you can grow, you can enhance your communities. So I keep saying to our cybersecurity majors, because you know some concepts and issues of cybersecurity. One, many cases, the skills missing is coding skills. So, so please, uh, mastering one language. There are so many languages available. Okay, um, not just a language in general, but language that you can quick implement and deploy, and also uh, utilize it in future uh, technical vehicles. Future technical vehicles, I think it is sensor, for example, wireless sensors, or mobile phones. Mobile phones is already saturated, right? Everyone has mobile smartphones, but still, it is although it is saturated, still that is currently that is the major technical vehicles that you can carry some new technologies. Uh, you can carry it always with you, right? Put it on your pockets, and you can utilize it, expose it whatever, wherever you are. So one thing that I mentioned the last time also, yeah, uh, smartphones, apps programming is very, very good area. That is the language that you may utilize. Uh, and Java fits into Android apps development, and C fits into iPhone apps development. But Objective C has been enhanced a lot. As I mentioned the last time, there is a language called Swift. Swift is a very good and fast prototyping language. But if you utilize all good features of smartphone capabilities, then as I practiced the last few weeks, in order to teach, I'm teaching the first time here iPhone apps development at the graduate. I've taught many years, many semesters for Android apps development, but now iPhone. Swift is good to start. It's very easy to implement. So simple iPhone apps programming, iPhone apps can be developed quickly in Swift, and there is a very nice and robust editor already developed. It's called the Xcode. A lot more robust than Android Studio. Maybe they enhanced since the time that I had been struggling with the Arduino, no, Android editor. I think it was about 2 years ago. Editor was really bad at the time. That was the first year they newly standardized their own editor. Before they developed their own, we used Eclipse. So Eclipse has the module that we can add into, so that we can develop for Android apps. It was good, but first year they standardized their own development studio. It was really bad, and that was the time that I stopped teaching Android apps programming here. And then since that time, I was thinking of iPhone apps. So this semester, I'm teaching the graduate level cybersecurity course. So that is the good language. Swift is easy to start, easy to implement. But if you want to fully utilize and communicate with external devices, then anyway you have to understand C, Objective-C. So many things, Objective-C's capabilities are simplified in Swift, but if you want to touch all small things in detail, then anyway you have to eventually go back to Objective-C's, and then you can maximize the capabilities. Meanwhile, there's a mobile technology. Still, there's big world, the web technology, web, internet, web technologies. So, assuming that everyone knows HTML, so simply you can type you can put it on your web page, you can visualize your table, text, simple images, and whatever, right? Very good. But still, there is some gap between web visualization and some animation, some of the work that you could do on your laptop. Is there any way that we can synchronize them? So if I make some animation here, if I make some um, sound effective sound effector here, there are a lot of such things available, right? But web, so limited. So MIT Media Lab recently developed very, very simple language. Very, 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 very simple. If you know Java a little bit, 131, not even 231, 131, then there's no problem of uh, putting some graphical stuff, so some animations on your web animation. Those who know HTML, CSS, you know it's not easy, right? Put some static documents on your web page. So far, it's simple. It is what? Can you make it mobilize it? So some of the animations works, or some of the animations can interact with whatever the users who can access from anywhere, South America, South Africa, Europe, anywhere. You put it on your animation, they can play with your animation. Idea is, again, very simple to the Arduino microcontroller framework. Microcontroller has two modules, actually, basic two modules. First module is nothing but like function or method in Java programs. Okay. I don't understand. Right? Methods, two methods. Okay. One method called the setup. Another method called in Arduino Uno it says loop. But in MIT Project 5 it's called draw. So initially we set up some drawing stuffs, and then in draw, whatever we change, whatever user click in response to some can be taken, right? That is the recent web programming, So apps development and web programming both are very, very important. And that comes to any arbitrary users, right? iPhone apps, smartphone apps, and internet web programs. And then they can join together also. It's not a big problem. Once you have a good web, then can be available on your apps. Language became so simple. So you may find out during this semester, if you are interested in study on your own. Of course, if you have some questions, if you bring some good issues to me, then we can discuss about anything that you think is a good idea, okay? Anything about microcontroller, smartphone apps, or web mobilization, web graphical user interface. So through the web, you can do so many things. It's not limited to drawing, sound, any multimedia. Um, Pick up small things. Uh, um, for example, if I say here, I speak something here, then pick up whatever you want to, extracting some of the features from the input in multimedia. Say, if I say some, that runs on the web. It runs on the web. But because I have a web browser, so that I can see that panel, and if I click start the button, so if it says speak, then I can speak, and then I can extract, for example, amplitude or some frequencies of my voice, or whatever it is implemented there. Okay, everything is ready already, but only thing that you need to do is to use it. Okay, MIT Media Lab already developed gigantic libraries. Simply use it. If you synchronize, uh, this is the editor. You see here, 5-star on my screen. This is that one. If I do this, a little bit of programming, then, and also it has emulator. So web browser. That runs as a server also, web server. So that can be synchronized with your web server if you have a web server anywhere. For example, VPS. Anybody has a VPS? Virtual Private Server, right? That's what VPS stands for. Buy a VPS. I didn't buy it. How much is it? I think about recent survey. I think I need to pay not more than $99 per month. But pretty good. But if you're so active, so that you run, actually you buy a server, and you have shell login ID, and also you can synchronize it with here another. Did you see here? CyberDoc, right? Doc is that animal to Boston? Sort of, right? Or Cambridge, above the river. I mean, then across the river. But it's called CyberDoc. So whatever you program here on 5-star can be synchronized with the server of your VPS. Then it displays. Then your web page can be interactive with the users, whoever out there. That is very, very important. Interactive. Okay. So, any question, comments? I'm trying to stimulate your research. When you do research, you could do something, some topics has been long, several decades, still unsolvable. You could do that. Another way that you can pick up topic is from the current. what something may come in the near future, there's another good topic, right? There's always some pros and cons. If you want to solve long-lasting, well-known research topics, then there are a lot of works already done and published, so that a lot of materials that you can rely on. The problem with that is, because it is still unsolvable, very unsolvable by you. I'm not degrading your capabilities, but very hard to solve. Let's say previously 1,000 people tried to solve, but unsuccessfully, right? Very hard to improve well-established, but something missing, right? Brand new topic. We start together, right? So if you pick up something from brand new technologies, then not many people resolve. So if you find out problems from the leading technologies, then that is the problem all the followers would like to also jump into. Okay. So the leading technologies include web, for example, web programming, or apps development, or sensors. They are all, each such areas, there is a cybersecurity issues. Whatever you are working on, there is some security issues, some privacy issues. Two things always exist: privacy and security. Security, so that someone else may break in. That's security issues in all levels, from hardware to software to data. Privacy, once it happens, so that somebody grabs the data, and then from the data sets, if somebody are identified, then there is a privacy issues. By looking at the data, oh, I know this guy. This is that guy. Then there is a privacy issues, right? So that is related with the design, and related to protect it. Usually, cryptography. Cryptography is so far the best solutions. Any data sets, if you encrypt it, then first of all, very hard to see the data itself. Number one. So first, protection, right? Number two, once it is decrypted, so that they know what that data is about. Therefore, if they can locate, if they can identify, then that is a privacy issue. So when you store data, you need to be very careful to make it anonymous, right? Anonymous. So by looking at that, then it's, oh, I do not know what that is. So there may be another piece of data needs to be linked with this, another piece of data linked with that. And then by linking more other resources, eventually system can understand who that person is, but it should be isolated by human tracing, from the human tracing. Okay, there's a privacy issue. Okay, writing. So Be patient. Any question? Any issue? Huh? Oh, you got group topic and your individual topic as well. Great. If you do not have a group, please find out who you want work with or who you think want to work with you. Two to four members together. But there may be exceptional cases, as I said, right? Can be reduced to one, can be bigger than maximum size, number 4. Could be number 5. Okay, what we have done so far, this is module 4 of my lecture in this semester. My lecture is only 4 modules in this semester, for this class. I'm not teaching you technical concepts or knowledge, but assuming that you know already some technologies from so many other courses that you've taken so far, but not well organized, never used your knowledge or skill sets to solve a small problem. So this is the class that we ask you to do that, okay? If you join the companies or some institutions, then they usually ask you to do from day one. If you are well paid, then from day one they expect something from you. If you are not well paid, then they don't expect you much. They still wait. There's always, right? If there is very high positions and good companies, then from day one they want to expect something from you. So usually 50% of employees' job is writing. If you write some garbages, then that is your performance. So write is something good. Some students are still confused. I do not know what to write. That is the reason that you need to do research from the beginning. If you do not have any problems to solve in your mind, then that at least I know you have some keywords, cybersecurity keywords in your mind. Sometimes it is a very broad concept. Let's say hacking, so broad, right? Then using that hacking keyword, you can Trojan horse, yeah, whatever, or yeah, find out some articles from Google search, or Mercy is a subscribing top journal papers, which is ACM. So you all know, right? So articles can be searched by keywords, or combinations of keywords, searched by author, searched by publish year, searched by some whatever. But year and author, not really big issue to you, right? You don't care. Whoever writes the topic that I am looking for, then you want to read. So keywords is the most effective and significant combinations. So with that, gather some uh, related articles, journal papers, conference papers, some magazines, or even Wikipedia. That is also good sources that you can start with if you do not understand what it is, right? For example, microcontroller, I said that, right? Uh, no one, there's no classes dealing with the microcontroller in good depth of knowledge, right? In undergraduate cybersecurity. But you will do if you come to graduate courses. You do not know that. Then microcontroller is a good keyword that you can start with. Then there is a that you can find out, let's say, some of the language issues, control issues, or encryption issues, and frequency issues, communication, transmitter and receiver. It's a lot of issues there. So you can pick one and go deeper and deeper. At certain point, then you need to start writing. If you do not have any idea, of course, you cannot write. You cannot start writing anything, right? You have to do some work at certain level. At that point, you define the problems, and you know some of the work done by someone else already. Then that is good time to start writing. Don't wait until the last minute. Believe it or not, as you write, your ideas can be elaborated so much. If you just elaborate in your brain, then maybe, oh, I have to do this, and also I need to do this, I need to do this, think more and more. You stopped all the directions. But once you start writing, then your idea will become clear, much more clearer. And then you will know which one that you need to elaborate further, while which one that you need to assume. Always there is a big assumptions and big contributions. Not always big contribution, but there's assumptions and contributions, right? So let's take a look how to write. How to write a great research paper. You don't have to worry about great. Okay. I do not expect great paper from you. I don't think I wrote a great paper in my life either. I published a few papers to very competitive and top famous publications, but I don't think it is still a great paper. Writing papers is a skill. So writing is a skill. No question about it, right? But how to write is a big issue. Not just simply write, but how to organize your idea. Which one that you want to write first? Which one follows? So all such things is a technique. If you watch some movies, some great movies, then a lot of impression, right? But if you summarize the movies, then it's not really that much big things, right? If you summarize it. But when you watch good movies, strong, it's very attractive. Therefore, you fall in love with that movies, right? They movies can extract your attention. Big motivations, and it solves the problems a little bit. So what happens is the best paper that I've seen so far is it explains some problems and solve that problem, and it indicates some other cascading problems. Because it is solved in that way, there may be another problem. And that problem needs to be solved again. So that solution also given in that paper. Then as you read that paper, then you know all the procedures. Oh, in this way it is solved in that. Then we can expect some side effect of that solutions. And by the way, that paper gives you the treatment of that side effects. Then that is good paper. There is no such medicines available. Because pharmacists are not really good as computer scientists, or not publicly. You see, some of the medicines, if you take it, it helps the symptoms that you currently have. Therefore, doctors suggest you to take, but doctor may not know fully the side effect. And also, pharmaceutical companies, when they produced, they didn't fully experiment that issue. Therefore, there may be some side effects. So I cured one problem, but I didn't know that I have another big problem caused by the first curement. There's a sad story, right? Always there's a technical barrier. But if you push that barrier beyond, therefore describe a little further, then that is the best paper. That is the greatest paper. Many papers are badly written. Good writing is a skill you can learn. It's worth learning. You will get more brownie points, more papers accepted, etc. Your ideas will have more impact. You'll have better ideas. Writing paper, module 1, model 1. You have an idea, you conducted research. You have an idea, you conducted research, and after that you write a paper. When I first wrote my master's thesis long time ago, I did in this way. I brought up new idea, and then I did research and completed my work, all the implementations done. And that is the point that I started writing. Okay. But that is not a good model. Good model is this. This is done that I had when I do master's thesis. When I did my PhD and afterwards, I'm doing this. If I have an idea, start writing. And then if there is something that I want to verify, something that I want to prove, something that I want to see how it works by myself, I'm also curious. Is this really work? Is this doable? Let's see. Let's try to do that. That is to do research. During the winter break, I wrote one research paper and submitted. I do not know it is accepted, but the idea is this. Well, when I was a student, I was studied artificial intelligence very much. One of my committee members is, his name is Dijon, Ken Dijon. He's also very, very famous in genetic algorithms, genetic. So program can evolve. What I was trying to do is to see how, for example, financial markets are evolving. Like any biological species, it evolves by itself, right? Financial Wall Street, it evolves by itself. It's not controlled by someone. Maybe there may be some such bad forces takes place, then usually it is criminal, right? Anyway, other than that, it evolves by itself. So it is very hard to anticipate. It is non-deterministic. Mutation is not deterministic, right? If mutation occurs, then we do not know. Mutation occurs at a very, very limited small spot. And it occurs randomly and very rarely. Randomly, rarely, and limited. That is the mutations. That's what I studied, right? While it is mutated, there is a more frequently there's a frequent operations takes place to generate offsprings. Usually biological two entities like male and female then combine together, right? It's called a crossover. So DNA can be crossover. DNA from mother, DNA from father can be crossover. So half of mothers, half of fathers can be in another, can form another biological entities. There's a crossover. So two major operators takes place always, crossover and mutation. Is it possible? Well, first of all, idea was, can we apply that operators into financial problems, crossover and mutation? Initially, we do not know. Oh, what is crossover in financial sectors? Think about a mutual fund. So funds that you invest consist of multiple stocks, right? So initially you start with the stock 1, 2, 3, like Google, IBM, and Apple. And then next month I would have Google, IBM, and instead of Apple, something else. That is a crossover. You have a series of stocks, and some of them are replaced by something else because you sell off some stocks and buy new ones. So new series of your investment is a offspring. Is something like offspring from mother and father. That occurs so often. So crossover can occur so often the way in all offsprings. So I get to that idea. And another idea, how can you do then mutation? What do you mean by mutation at the financial sector? Mutation occurs randomly, rarely, at limited spot. What is mutation? There's a lot of such things available, right? CEO replaced by CEO of some companies replaced, or some companies relocate their manufacture facilities from China to Vietnam, or Vietnam to back to Georgia or Alabama, something like that. That is a mutation, a little bit of mutation. Something changed, right? A real random mutation may be affected by some other products, like oil money. Saudi Arabia's oils is affected by shale gas, shale oils produced by America. We never expected that, right? That occurs through that Saudi Arabia's crisis. Another crisis in South America, or what is the country? No. What is the country's president? Previous president was Chavez. What is the country? Venezuela. Venezuela. Venezuela is a big crisis, right? It's, it's worse than bankrupt right now. Think about that. 2 years ago, Venezuela was really good because they have plenty of petroleums. Only if they pump it, sell it, that is their own money. Now, no one wants to buy their products. So whole country bankrupt. There's a mutation, right? But anyway, so writing paper and do research. So I elaborate some of the ideas. Okay, how can we, for example, think of changing my investment based upon stock symbols. For example, AA, then I don't know what that is, but Apple, IBM is IBM. Google's symbol is GOOG, for example. Amazon is AMZN. Those are symbols. So can we change some of the symbols abruptly? Change it if it also available stock symbols, then there is a possible mutation. And crossover, same thing. There is a symbol mutation, symbol crossover. Data mutation and data crossover also possible. And group of those, like mutual funds, multiple series of those symbols. So part of a symbol is replaced with another symbols. So three phases of operations possible. So describe that and then do research. Can we do that in programming? So I did that in Python. It works. I spent several nights and days, and finally my Python programs works. It connected to the Wall Streets and downloaded some data and changed some data and changed some symbols, and again check with the list of symbol list to see if it is available there. We keep changing a little bit of those, but randomly. So always a random number needs to be generated so that to see if finally it is meaningful. Investors do not consider all the stock symbols. That is our humans' limits, right? But if you run a program, that the program look at all the symbols all the time, a lot of iterations. Okay, so keep in mind, this is the procedures of your research. Once you have an idea means you have a problem, you know how to solve this problem, then that is the idea. If you have a problem, you know how to solve. You do not know elaborates. It's not elaboration needs to be done. But you at least you know that, oh, I have this problem. Oh, I think in this way this can be solved. Then that is the idea. Idea is formed, is defined. Then write paper. Try to see some block diagrams. What smaller modules required to solve that problem? So you have multiple small modules, small components. Some components that you can do, some components that you cannot do. Some components is already done by someone else. So you can simply refer to it. Solve the problems, you need to have, let's say, 10 small blocks to be considered. 9 of those blocks are already done, or there's too much. That's fine. You can bring up those small blocks and then pick up one small block that you can handle. That is the block that finally you can do research. If you can do mathematically, fine. If you can do small implementation, even better. None of them are possible, but you know how to say, how to describe, then describe it. Although it is not mathematically, although it is not program-based proven statements, still fine. Describe. That is all I want from you. Okay. In that way, well, each one might have a different contribution, right? Somebody, if they did a little bit of implementation, then take that implementation to your interviews. It is much, much more effective than simply saying that, hey, boss, I know if you hire me, I will work so hard for you. Everyone can say that. They can interview thousands of applicants. Everyone tried to say that way. But if you show, hey, this is skill that I can start from day one, but I have planned to elaborate this and enhance these issues further and further. That way you can succeed, okay? Crystallize what you do not understand. This is also very, very important, right? By decomposing the problems and solutions, you know some blocks that you do not understand. That is fine. You can figure that out later. You can put that in your future research. That is also good. You do not need to solve all the problems. There is no such person can solve everything except Steve Jobs. Well, he has big group under him, right? Thousands employees working for him, but probably ideas mainly invented by him or originally from him, but that is the output. That is a product of their collaborations, right? So there is no such work done by only one person. So don't worry about it. Do not think that I expect much from you. Okay? It doesn't mean that I do not expect anything from you. I expect something from you. Okay? Right, not any something that you could do. I know I was so bad when I was at your stage. So I know, right? But this is, I think, some of you, this is the first time that you write some of the idea on your own, right? This is the first time, then this is good moments that you can jump your stage. Open the way to dialogue with others. This is also important. In this way, for example, in this semester, we have an individual presentation. You need to learn, you need to hear some presentation from your peer group. So you can see, oh, that guy's doing that way. Oh, the other guy's doing another way. So you can learn something from your friends, right? If you know only on your own, and if you don't share with others, then you think yours is so bad, or you think yours is so good. May not be true, right? Yours is very similar to others, but by learning something from your friends, you can enhance your work. You can improve your work. Therefore, you can take that lessons to your group project. Paper writing is like teaching. So by writing, you can teach your idea to others. Not just the summary. Writing is not just summary, but delivering, conveying to others. By writing your idea, if the readers can understand what you are thinking, then there's a teaching, and that is a success story. Well-written papers contribute more than just their described result. It impacts on someone's idea also. Not just your presentation triggers the audience to make further more progress. Big contribution. Idea. Many papers contain good ideas, but not fully distilled. What does that mean? When you read some references, those papers are not fully distilled, meaning there is something that you can do further. pick up some missing gap from the paper that you are reading. Something undone. So when you have an idea, then you can describe it in this way. Here is a problem. It's an interesting problem. It's an unsolved problem. So here is my idea. My idea works in this way with this data, and so on. That is a flow. There's a flow of your presentation. There's a flow of your writing. Okay, very simple. That is the organization of your paper. Don't say something else. Therefore, the number of pages of your writing is not important. You need to say in straightforward, hey, here is a problem. Describe problem. Interesting problem. A problem is a broader problem. There may be small interesting problem. There are many interesting problems, but some of them are not solved. So I'm going to solve this problem. And this is my idea that can resolve that problem. Up to that point. And then elaborate further. How? You can design some block diagrams. Some block diagrams that you can handle, some you cannot, some handled by someone else already. And do a little further, that's small things. Okay? Clear? You have to practice it. If you don't practice, you do not know really how it works. I think this is the main point that I want to deliver to you. I mean, throughout the whole semester of this class. Others, for example, title. Oh, this is how your paper can influence. Title can be read by 1,000 people. Abstract usually 4 sentences or a few sentences can be read by 100. What does that mean? Title is very, very important and should be very, very specific. If you say how to hack in cyberspace, it's interesting, but it's so broad, no one wants to read even further. But if you say, how to breaking the Trojan horse based source code that can run on your firewall, for example. More specific, so that somebody wants to, I want to read the abstracts. So 100, only 10% who are interested in the title can read further the abstracts. Introduction, usually 10% of people. Problems, 1%. So they read abstract and introduction and problems. Idea, 10%. Details, ideas, 1%. Details, 0.3%. So details is important, but what I want you to focus more on is title, abstract, introduction, and problem. Of course, details is but that is the impact. Related work 1%. Conclusion, most people wants to read the conclusion also. In my case, if I want to review the paper written by someone else, then I read, first of all, title. Title is very, very important. One phrase, right? It's not a phrase. One clause. It's not complete sentence at all. Somebody's write the title in complete sentence. But that's meaningful sometimes, right? But usually it's not complete sentence. So we call that clause. Right? Clause. Abstract. I read the abstract if I am interested in. If I do not have time, then I read introduction and conclusion. Introduction so that this guy really understand the world. And conclusion. Usually they said, oh, I solved these problems in this way in short paragraphs. That's a summary of their work. And after that, if I want to learn their technique, then I need to go back to see the problems and something about the idea and details. Okay? That's it. So think about this. Okay, let's take about 15-minute break. When we come back, what time is it right now? Yeah. When you come back, we'll take another hour to start writing. Okay. If you do not have an idea, then anyway, we have to start writing today. Don't wait. We have only 3 weeks to complete individual project. So you have to start writing. Okay? Let's take a break. All right. So if you do not have a laptop, then bring up paper and pencil so that you can start writing. If you have a laptop, you can open up any editor. Microsoft Word, fine. Usually when I do writing to elaborate my paper, I am using Google Docs. The beauty of Google Docs is like this kind of research work. Can anyone say? Share, yeah, for collaboration. Shareable. Another? Right, there's a shareable, yeah, anywhere. Can be, yeah, right. Shareable and accessible anywhere. You can work on your laptop. At some points, you do not have any one but public PC, for example, in the public libraries, when there is a PC, so that still you can access if you start working on Google Docs. What else? The beauty of Google Docs. The one that I really love is the version control. If you work on Microsoft Word, then you can keep only the current version, unless you rename it, unless you copy it and save in separate independent files. There's no versions can be maintained. But if you're using Google Doc, then automatically you can trace back. For example, oh, I write some paper, something and I updated, and current version at some points, for some reason, I do not like the current version. So that I want to go back to the version that I had, for example, 2 years back, 2 days back. Then I can go back for 2 days and then bring up that version and start from there. Okay, so that is something that you can do. What is this? Change the color. I don't want this. So I'm not teaching you Google Doc, but as I am working, I want you to work also. Okay. So actually, title is very, very important. You and I start together. Okay, writing a paper. So soon as I finish up my title, another thing, while you are writing, you're probably not ready to write good sentences, although you have something in your mind, right? So picking sentences are very, very important. Then, first of all, you have to start thinking how to write. But if you reaches the dead end, so that you feel, oh, I don't know, how can I describe? Then go back to the paper publication and read the paper that you already read one more time and find out some sentences impacts you a lot, so that you can, oh, this is something like this that I want to write. Okay, so you need to, while you're writing, you have to read. While you are reading, you have to write. So that is always back and forth process.
So you recommend like when you're reading it after other papers, like highlight it before you scan it?
Oh yeah, something that you think, oh, this is a good sentence. Then you can highlight it and go back to get some idea when not just the idea, technical issue, but sometimes that may be my case. I mean, even worse in my case. I need to find out, oh, is there any other better way that I can describe the thing that in my mind? Okay. If you simply describe it, then sometimes it's not fully expressed. Okay. That's my tip. So always, while you are reading, you have to write. While you are writing, you have to read. Full paper. Proposal, I asked you to write up to some points, right? Like problem descriptions. So maybe about 5 pages.
Wait, so you want the paper sent to be 10?
Hmm? About 10. Why? Too many or too small? Too many?
I thought you said as long as we able to like, I thought you said
Yeah,
the page
fine.
number don't matter, but as long as you're able to go with the.
Correct, yeah. But I think it goes up to 10, right? Can you describe all in 2 pages?
Maybe 3.
Yeah, I think about 5, okay. 15, okay. So about 10 means, yeah, about
Does this include pictures?
everything.
I think the whole thing.
What do you mean by it? Why that makes you happy?
Pictures.
Why?
Because it makes sense.
Yeah, everything. Yeah. Sample paper is the paper that you can access from anywhere, right? Those are the sample papers, but they are too high quality. Yeah, I know some since requested papers submitted last year. but I don't want you to be influenced by the work quality and organizations done by yours. Right. There's open. I know you open potential. So don't be. If I show to you, then automatically you feel, oh, this is my upper cap. So let's try to do only up to these points. Oh yeah, already. You've never come to the Blackboard yet? I posted all day one because it's all ready, right? Everything is ready. It's not. There's no evolutions. Sample paper is paper like that I am now writing. And another sample papers that you can find, for example, we can all together go to, if you do implementation. No, just the citation. The way, if you look, for example, one of the paper, this is a good example that you can reference not only the content but the structure, organization. Any paper that you can find here, that is a good model.
So should we reference it, like cite it?
Yeah, I'll show it to you how you can reference. It's now slow, but works. Let me see. Oh, still recording. Okay, this is JS graphs of join and split trees. Well, actually, this is not what I want to find, but this is kind of paper. You don't have to make. Don't write two-column paper. Don't write this small fonts. Don't write this narrow line spaces. I want to write at least one and a half line space. Double space fine. 1.5. Recommend single column. So about 10 pages. It's not really big. I mean, I'm not asking you to write a single line space, 10 page, but double line space, which means if you write it in single line, then 5 pages. And structure is similar to this. You start with abstract and introduction. Don't follow this. You don't have, because you do not know general terms and keywords. If you have keywords, you can write in this way. And then at the end of this paper, there's a reference. Okay? Follow this reference. Say there is a number one, some numbering systems. You label, there's so many ways. This is, number is, that appears from, smaller number appears earlier of this paper. Earlier cited, or some other cases they do these numbers alphabetical order of the first author. I'm not sure how it works in this case. Base, this is start with B, and car. Maybe this is the alphabetical order of the first author, right? Corman, oh, not really. Bart again. So this is not author order, but the way it appears, the way it reference. For example, if you read this, oh, it's not really. This is not good paper in this way. It's number 8 and number 1 to something here. It's not really the way it is cited. It's not really the way it is written by first author, but should be consistent in your case. Either alphabetic order or the order that you cite in your paper. So this should be number one, and number 2, 3, 4, 5, 6, 7, 8. That is one typical way. Another way is that you can do it alphabetically, the first author of the paper. Like this time, you may encounter this issue also. I'm looking at p5.js. I'm trying to write my paper while I'm here with you. Practicing coding skills for interactive multimedia visualizations in web servers by non-technical majors. Trying to find out some references from famous publications like ACM. So there is no publications for p5.js. Then I need to come back to my Google search. From the Google search, the keyword that I was using was I think p5.js benefits. This is a place that I can describe by comparing. This is an article by someone else, right? It says, what are the benefits of, or why should we be learning Java, JavaScript, and Python for processing? p5.js, P stands for processing. How typical programming languages help or visualize the processing of anything. Okay, speech processing, speech recognition, or drawing. Drawing is kind of a processing. So somewhere here, it seems that p5.js is extensive explorer and make use of JavaScript libraries on the perspective of manipulating web browser and animation with the web for processing. Am I right? How about Java and its own unique or strength of areas? This is kind of some questions and answers given by someone else here. This is the first time that I can see. So by reading this kind of articles, then you can get some clear idea about what to write and how to write and what to achieve. Okay. So did you fix the title of your writing by this time? I wanted to share yours. Anyone done?
Still a very simple title.
That's okay. I mean, I know title can be modified until the last minute. That's how I do. Why? You started with one title. As you write, as you elaborate, something hits upon you so that you change it, tweak a little bit to different direction. And therefore, it doesn't, the previous only title does not represent your work. So that you need to tweak. again, your title. So everything is back and forth. As you read more papers, so that your writing and issues and ideas needs to be a little bit tweaked, and therefore title. As you write title, as you modify your title, something came up your mind so that it reflects and affects your writing again, and therefore you need to find out additional another set of reference papers. So all living process. This is another process. So don't be afraid of sharing your title. I want to see. I want you to start. That is very, very important. Start today. Okay. Aaron, what is the title that you have? Huh? Any word? What are you thinking of? What's the keywords in your mind? Anyone?
I put out pacemaker problems with wireless synchronization.
Right. Very hard problem, but eventually I think you need to
Yeah, I wanted to be
narrow down a little further, uh, simplify your problem. I mean, simplify means right now problem is too big, therefore find out small problems, something doable, specific.
Mine is, should we trust RF technology to detect our credit card information?
Okay. What do you think? Is it broad or specific?
It's a good idea where they have the chips,
Oh yeah.
chips on the credit card.
Mhm.
So it's unique to each credit card, but who knows how safe that actually is.
Is it RF chip or I do not know. What chip is it? Is it RF chip? Then why we push into the machine? It can read in some distance.
They have like two signal generators. I forgot what the first one was.
No, my question is, if it is RF chip, then radio signals generated so the reader can read in certain distance, not necessarily plugged in, and then usually it says don't remove, and then until some beep comes, and then it says take it out.
Usually the tube is where you can just kind of swipe.
I know, swap is old technology, but RF chip itself.
No, but the RF, you can just kind of pass the card over and read like tap thing. Yeah, I mean, or like you said, like you have to like, put it into your reader. Like the military, they have like their IDs work like that way too. Like you have a terminal with a keyboard that has that reader, and you can't access it unless you have that card.
Physical contact.
Yeah.
Is there any way to wirelessly?
That's I'm assuming that's the idea because they're like it's somebody who's like trying to steal information, and they like have a reader that you just need to get close to somebody, get close to somebody's handbag, and you can pull information off that card.
Is that what you want to? Okay, so now everybody has credit card. Almost all the cards right now RF chip in it. So that if you have a reader, then just approach it to someone's like handbag or back pocket
Just be close enough.
and cross it, yeah, and then read their. Is that what you're trying to do?
Yeah, the study is that chip has caused like less debit card and credit card fraud.
Yeah. Find out some of the approaches already done right? I think, yeah, I think a couple of years ago, some of our graduate students tackled the issues, but no demonstration, no implementation so far. Think about if you do real simulation, real practicing, you'll be hired by Visa credit card companies, American Express. Anyone else?
I don't have Kyle, but I'm looking at something with flexible technology. I'm going to try to get flexible technology, where that's going to create with that.
How can you explain a little further of your findings so far?
Like, you know, the little RFID chips that people can buy themselves.
Like for IDs, like the swipe and then.
Yeah, like the same thing that's in the credit card, you can just put it in your hands and stuff. And like,
There's been an issue. I think one company they got rid of the IDs because they started planting like an RFID chip in your hand. They just
one company in Sweden,
yeah,
yeah.
yeah.
So it's a bio RFID chips.
Yes. But that opens the way to new implants or anything like or if you can if it's not property you can use it to take to vital sign information and it could be like something somebody who monitors it like for certain patients instead of having to have this thing like me work in medical you deal with patients that sometimes have to wake them up in the middle of the night just to get their information. But if we have that kind of technology like implanted, you don't have to bother that patient. You don't have to wake them up in the middle of the night just to
Right.
get information.
Yeah.
You can just look at the screen. You can see everything there.
There's a company here, they put chips in the arms or right in your shoulder. And a lot of people like just put them in.
I heard and I've watched some of the documentaries, but I've never seen a real person who has. Oh, you do?
This one,
Wow.
too close to the surface, but
What? Yeah, I noticed.
yeah.
So
Just,
why in your case?
You implanted your own chip?
yeah,
Oh, yeah.
I'm just gonna see if I get it. So this one's like all synced up to my house. So when I put my hand on my doorknob, the deadbolt opens. When I walk into my room, it opens it up. It's hooked to my safe. My computer.
Oh, you do that?
I wired the whole thing. Like I walk in my room, I can turn the lights on. I put my hand on my desk, the computer unlocks for me. And then this one is NFC chip. So this one can unlock my other phone. I have my name and phone number, so like if I want to share my contact information, I can tap someone's phone. It'll pop up.
Ah,
Yeah.
that guy is real techie.
Yeah.
Or what about from medical perspective?
Yeah, once they have a readers, then yeah, he can be.
Well,
Right.
I didn't just buy a chip online, Steve. No, it was specifically made for it. So it came sterilized and everything, and all day. Like I sterilized the whole area, and I drew diagrams. I didn't know what I was doing. Yeah, so no, it's a needle. I put the in his hand, and then I had to cut this one out and put it back in because
It's like a gun, right? You just kind of like.
it's just a little it's smaller than the thickness of a pencil. You kind of just
What kind of data that it generates so that the other device can understand? Do you know that?
This one just has a unique ID number on it.
Unique ID number.
Right,
Okay.
and I
Okay.
changed that kind of
Stop there. Unique ID. Okay. The problem in that case, I'm telling you, so that you can investigate further. Once that ID is lost, then there's no way that you can fix. That's you can change your
I changed
right.
at least once.
Right, then that is good. But some other identification systems that can identify you by your iris, from your eyes, or from your speech, from your voice. Once it is hacked in, so that somebody mimic your iris or your speech, then there's no way that you can change yours. Once it is compromised, then there's no other way, because that is your natural. Somebody took it, then how can you upgrade yours? How can you change yourself? Change your eyes, change your tongue and everything, right? There's a big problem. So biomedical based biotechnology based authentication. Once it is break in, it is a big disaster, because no way that you can change it. Chip, okay, right? So that kind of chips. So that is a good solution to solve that problem. Partially because that is in your body, like your voice or iris. But once something happens, then you can change it. So that is a good solution to solve the problem that I just described.
So then by that, I understand that you have fingerprints, like fingerprint imprints.
Right. If somebody copy your fingerprints, how can you change your fingerprints so that you can have your own unique fingerprints?
I think that comes with this. I remember watching Mythbusters. They were like looking for ways like to fool biometric sensors, and it's actually very hard to do so.
It's very hard, but once it is,
Yeah.
right. So that is not good solution. Chip, put it in your biological body, maybe a good solution. It is unique until as far as you keep it. But once it is compromised, get another.
But with the chip, is it like there forever?
Can be, yeah, can be.
I don't have any bonding on it, so like I can take this one out already. I can upgrade them to new ones, and I can also just change the information on
So
it.
there's no like flushing it out?
No, it stays where it is, but like if I need to, I can turn it up on an amp and just take a little scalpel, make a little.
Wow.
It's like you can't really travel from your body from here. It's kind of
Yeah, it stays true.
there's lots of little bones, lots of little things that you can like put in between, so it kind of stays put.
No,
It doesn't flow inside
Yeah, that's what I'm trying to say.
and digest.
Well, no, it's not because then if you don't put it into your veins, it's not gonna it's not gonna flow away with your hand.
So like glass, unbreakable.
Yeah.
well, it's biosafe glass, same thing you use in like medical implants, and then it's filled with enamel, so it's not like it has hollow spaces to crack. I think you can like keep it in
So
there.
it's like a solid pill, basically.
Basically, like you.
What is the material of that? Physical material.
The outside is like a biosafe glass, and it's filled with.
Is it glass? Kind of glass?
Yeah.
You think
But we call it glass, but it's not really
It's
glass.
like
Right?
medical. It's not like glass, like
Right.
like, they did a bunch of tests on it, like they dipped in nitrogen, hit it with a hammer. Like this thing doesn't break.
It didn't break, right?
It's ridiculously strong, so I'm not worried. Like I hit this thing all the time. I don't feel the tear. It doesn't
Oh, is that
bother
right?
me. No, that doesn't bother me in the least bit.
So it says it's
You can actually go down a little module. You plug into your car, it starts to unlock your car. That's with like motorcycles. They put in the handlebars, so when they get on the motorcycle, it will start for them.
That's dope.
actually you can probably.
Have you tested it in some temperature, like stay in the sauna for 1 hour, and melt, or go to North Pole and stays frozen yours and
So wait, you mean like as if like temperature with the
yeah.
Well, the only problem with that is the chips I have in my hands are, like everybody's always like, oh, what if somebody cuts your hand off? Well, the chips I have a low temperature thing in, so if my core body temperature drops too much, the chip just dies and will never work again. So they can never just be taken out of my body and put somewhere else.
Something about that area.
Yeah, well, like literally they kill you by the time they
No, but that's smart though. I think that's also part of like what the fingerprint sensors do. You know, like it's like if somebody just has like, you know,
It's like the kill
like a
switch.
weird blood or something like that.
Because they're easy enough for me to change and put a new one in, so
So ID, is this something that you assigned, or once you buy it, ID is
well, it comes with an ID,
printed?
but then you can reprogram it. These
Oh,
are
yeah.
completely reprogrammable. I can put anything I want on them just by running them over a reader.
What is the size of
Oh,
ID?
okay.
What is the size of ID?
This one has This one is 888 bytes. This one's now, what is it, the new one?
You don't remember your own chips?
Wow,
No, I changed one. This is the new one. So this is James was telling us.
I gotta just look at
Oh, this one's just like
It's called Dangerous Things.
No.
It's called Dangerous Things.
Yeah, dangerous things. And they sell like people put implant magnets in their fingers. Like I have a whole couple of implants in there. And they
This is like
people put like a magnet in their finger, and they like have a device that you wear, and like you can feel like which way's north. But then they use it for like finding electricians use it or electrical engineering finance find like you know the current of the walls where the wire is if the wire's lie. There's a lot of like little things you can do with some of these implants.
This is like days like
About the computer, there's a flexible silicone computer that you can put right underneath your skin and monitor your glucose, blood pressure, everything. It syncs with Bluetooth so you can get it all onto your phone and stuff. It's great.
Wow. I wonder if like it has an effect on the plasma.
These have no, well, these don't have a coating right now. So the ones that the company was putting in people's arms had like a biobond coating, which made it fine to the muscles, so it was more, it didn't move and it wouldn't come out. And then sometimes reacted poorly with people's bodies and cause cancer. These have nothing on them.
Cause cancer?
Yeah, in some cases. But these have nothing on them, so like they're completely safe. Like, there's nothing for them.
Wow, great. So
So
we are looking forward to the research work accomplishment. What I wanted to describe, although you write something else, how you have a reader, right?
Yeah.
You said reader and that device chips. What is the communication between?
Put them right over it. Oh, this is 125 kilohertz. This is 13.56 megahertz. So this is NFC. This is 125. So standard.
But signal is not emitted from that chip.
No, these are passive devices. So
Passive, right? So there's a reader. Reader needs to trigger it.
Right. Yeah. Oh, also in the new dorms, when they hook the elevator up, we have to swipe our card. I can open myself up to the floor because this has my ID number on it, and I can just.
Oh, school ID.
Yeah.
Is that how you do?
I have a bunch of different things on this, but one of the things is a school ID, so I can just bug myself up.
You can literally access into his door.
Yeah, so I don't need to carry my ID.
Even when we walk in, we swipe our card.
Not the reader outside, they don't have the wireless thing, but the ones in the elevator, the ones all around here, to get into like the tunnel and everything like that, those all have the wireless piece, so I can just tap my hands in them.
Now I think we all need to hack his ID, and we can behave as if we are him.
You have to jump up, move them down, get a reader.
These don't pose any problems with Airport Scoop.
But they are looking for that.
Oh yeah.
If I get that, I will no longer be allowed in government buildings in New York.
Oh.
As they told me they would no longer allow me in. We're not even like when you go into a building, like I work at one of the buildings and they take everything, they have flash drives, everything off, and they're like, yeah, if you have that, we're just not going. They already hate these, and these don't do anything.
They see it? Do they see it?
Oh, they know. I had to tell them.
Oh yeah, you can't just keep this up there because if you find out, then
They do sweeps all the time for wireless sales. But she's probably wouldn't show up because they don't have batteries, but I just told them.
That's right.
But the one in the element like gives off a signal. Would not be allowed in the building.
So sure, let's just find out real quick.
I didn't get that yet.
Interesting.
Very interesting.
Yeah. So at your individual presentation, are you going to give us some demo of what small things? Yeah. How to
I have this little
how to
board
others?
that I use for demonstrations, and it's all set up with the arc video.
Okay. That's great. Anyone else can share the title that you have so far? All right, I want you to continue to work. In the meantime, if you have any question, any issue, by the way, every other week, Friday, we will, I didn't send that to you. but online students. But I want to tell you here. Every other week, we will have a help session, Marvel Hall Cybersecurity Lab, Friday, every other Friday, from 3 to 6. So if you have any issue, any difficulties, or anything, not only this course, or if you are taking some other courses from me, you can come to that session so that you can meet me. So other Friday, the next Friday that we will meet there is not this Friday, but next Friday. Not this week, but next week. Okay? So you can come next week. And from that time, every other week. The reason I'm taking help session here every other week is because another week, another Friday, I'm going to be on Manhattan campus. If you can come Manhattan campus the other week, the other Friday, that'll be fine too. Okay, I can meet you over there. So one Friday I'm here, another Friday I'm at Manhattan campus. Okay, sometimes I change it because if I have to be here on particular Friday, then I switch those Fridays. Okay, so if you text me, then I can let you know. For example, oh, I want to see you.